Hi everyone, this is Mrs. Myers with a study guide review. Hopefully you have already completed your study guide, and what we're going to do now is go over the answers. So as you look at your own study guide, I want you to think about any mistakes that you've made and correct them, and then have that study guide ready for our test day. Okay, let's go ahead and get started. We are on Unit 2, so we've been learning about algebraic expressions and then surface area and volume. So the first thing to point out, you have here your order of operations. So we know that the G goes with the grouping symbols. That includes parentheses, the fraction bars, the bottom beneath the fraction bars, and also absolute value. Those are grouping symbols. Secondly are exponents, and that includes exponents as well as square roots. So if I had 4 squared, I would evaluate that. That means exponents, just like the square root of 81. Both of those would be considered exponents. Next, we have multiplication or division, and these are whichever come first in the problem. So multiplication or division could be whichever one comes first. So sometimes division comes first, sometimes multiplication comes first, whichever one's in the problem. Same thing with your addition and subtraction. So you are looking in order from left to right. All right, so let's go ahead and get started. So when we have an expression, we have the steps that are listed here. You're going to substitute the variables with their number value, double check you wrote the number correctly, evaluate following the order of operations, circle your answer, and then don't forget to show all of your work. So for these type of problems, if you look at the one on the right, what we can do, we've been doing in class, is using Desmos. So I thought I had the Desmos calculator here. Here we go. So if I was going to do this evaluated expression using the Desmos calculator, I could do that. And what I would do is simply type in the expression just as it's given. So I will put in the absolute value sign, and then I have b minus square root 225. And then I'm adding to that 16a. So that's our expression, and using Desmos, we can just now tell Desmos what the values are of a and b. So we're going to go to our next line. I'm going to go ahead and make this bigger for right now so we can see it. So if I go to my next line, I know that, let's look at the problem. A is equal to 0.5 and b is equal to 8. So a is equal to 0.5 and b is equal to 8. So just type that in my calculator, and if you notice up here, it gives us our answer of 15. So our answer is 15 at the top. So I can go ahead and write that as my answer. So the answer to this one is 15. Next problem, we're evaluating if G equals 81, J equals 16, and F equals 5. So I can do the same thing again with my Desmos calculator. I'll pull it over here, and I'm going to clear it, and I'm just going to write this expression, square root of G. And then for this one, you've got to click out of it so that it doesn't put the rest of the expression inside the square root sign. So the square root of G plus parentheses 5, and then over here, if you want to raise something to a power that's not 2, you press this AB button. It's going to be the power of 3 minus 4J, and then I'm going to get outside the parentheses, and on the outside of the parentheses I have plus F. So I got to go back to my variables. Okay, so that is my expression. See if I can pull this over a little bit. So I can go to my next line, and now I can tell it the values of G and F. So, G, J, and F. So G is equal to 81, and I'm going to enter. And J is equal to 16. And then finally, f is equal to 5. All right, there we go. So if we want to see the answer, I guess this is looking a little small. I'll just go ahead and make my screen bigger, and you can see that your answer is up here, the 75 at the top. So I'm going to go back to my problem, and the answer is 75. All right, next problem. Same thing. I'm going to grab my Desmos calculator, and I'm going to type in my expression. So if you notice, it starts with 1/2, so I can put in my fraction key, 1 on the top, 2 on the bottom. I'm going to click out of the fraction. I'm going to click my parentheses, square root key, 121 plus y, and then to the 4th power. So I'm going to go back to my main, the a to the b right there, the a to the b, and that's going to raise it to the 4th. I'm going to get outside my parentheses, plus x. And again, it's telling you here, you don't know what y or x is, so it's not going to allow you to solve it quite yet. So you're going to go to the next line, and I'm going to tell it that x is equal to -2. And I'm going to go to the next line, and I'm going to tell it that y is equal to 3. All right. Let's double check, because we did get a weird decimal for this one. 1/2 square root of 121 plus y to the 4th plus y. Y is equal to 3. X is equal to -2. Okay, looks like we got, we're going to round this to the nearest tenth, 5 1/10. Okay, so the answer is approximately 5 1/10. All right, so again, these are really easy to solve using Desmos, but you also have to keep in mind sometimes it'll ask you what the first step is. So for example, if we looked at this problem here and we wanted to know what the first step is, we're not going to know the first step just by putting it into Desmos, because Desmos does all the work for us. So the first step for this problem, we're going to think about our grouping, exponents, multiplying or divide, adding or subtracting. So the first thing I'm going to do is I see a grouping symbol. So I've got this grouping symbol. Within the grouping symbol, I have an exponent, I have subtraction, I have multiplication, and we know that exponents come first. So the first step in evaluating this expression would be, I'm going to evaluate 5 to the 3rd power. And again, that wasn't on your study guide on this page, but I just wanted to review, if you have such a question, how you would do it. So we still need to know our order of operations, although now we're working on our Desmos that does a lot of the work for us. Okay, now we're going to look at models of expressions. So we worked with these models at the beginning of the unit. So you're going to take a look at the key. The key is very important. You need to always look at it because it could change. You could have pictures of different things, not necessarily shapes. In this case, we do have the same type of picture that we used in class. So if you notice here, we have these 4 long, skinny rectangles that have negatives inside. So because of that, we can see that they're -x. So what that means is we have 4 of them, so it's -4x. Okay, so that's the first part. The second part, the second thing that we have here, it'd be nice for you guys to use your highlighters as well. You can look at the small squares, and we have 2, 4, 6, 8 of the small squares, and our keys tell us that, or our key tells us that they are -1 unit each. So that means we have 4 negatives. So I have 4 minus 4, okay? And that we talked about in class, oh, excuse me, not 4. We have 8 of them. We have 4 sets of 2. So that's going to be -8. And I know the question sometimes is, how do I know if it's addition or subtraction? Well, in an expression, it's showing that all of these things are combined together. So when we're combining models together in an expression, we just need to say what I have. And when I think of combining, I think of -4x plus, because I'm combining -8. And -4x plus -8 is equal to negative 4x minus 8. And that's because, as we learned last year in 6th grade, adding a negative is the same thing as subtracting a positive number. So the correct answer for this one is going to be negative 4x minus 8. Moving on. Now we're going on to volume and surface area. So one of the things that's important is that we recognize the keywords for volume: inside, cubic units. When we fill something, something contains something, or it holds something. Whereas with surface area, it's going to be if you're on the outside of something, like outside of a box. Square units, you're painting the outside of something. You have a label, like the label on a can is on the outside of the can. If you're wrapping something with perhaps gift wrap. If you have paper that's covering, and there's cover. So these are keywords that are going to help you figure out whether it's going to be volume or surface area, because that's going to tell you which formula you're going to use. So let's take a look at this first one here, steps to build a jewelry box. So the question is, in what step would you use volume? So let's take a look at each of these and discuss them. So the first one, cut the wood into correct measurements. Okay, I don't think that sounds like volume to me. That's just getting the wood, figuring out the wood that you need. You're going to nail the wood into the rectangle. You're going to attach the lock. You're going to paint the outside of the box. If I'm painting the outside, is that volume or surface area? That's right, it's surface area, so that's not going to be it. But the last one, if you notice, we have that word filling. I'm filling the box, and when I'm filling something, that's going to be volume. So step 5 is the step in which we would be finding the volume. All right, let's take a look up here. Now we're looking for situations that would require the application of surface area. So surface area, again, is when we have the outside of something being covered. So determining the number of erasers that fit in a rectangular box. That's going to be volume. Determine the amount of paint needed to cover a cylindrical tube. Okay, so if you're painting something, you're not typically pouring paint inside of something, you're going to put it around it. So this would definitely be surface area. And our keywords, we have some words here. We have cover, and we're painting something. Typically when you paint something, it's going to indicate surface area because you paint the outside. The next one, determining the amount of plastic wrap to completely cover some brownies. Okay, that would be you're just going to cover the surface. And so cover, that would also be surface area. The last one, we have determining the amount of corn inside. Again, we've got that word inside. So we're not just putting the corn on the outside of the can. It's not just on the edges. It's actually inside the can. So this is going to be volume. All right, now that we've practiced looking at the difference between surface area and volume, let's go ahead and try some problems. So we have a net. We're going to look at this net of a rectangular prism, and we're going to find the volume of the shape. So to find the volume of the shape, let's look at the formulas we have over here. So to find, you should have your formula sheet, but to find the volume, we're going to use, we have the rectangular prism. It tells us it's a rectangular prism. Oh, I should highlight that. It tells us it's a rectangular prism. So we know that this shape here is a rectangular prism. And then the formula for volume is going to be length times width times height. Okay. So we're not finding surface area with this net. This time we're going to find volume. So for finding volume, we simply take the length, the width, and the height, and we multiply them together. And since this is folded into a net, we can see that there are, or unfolded into a net, we can see that there are 3 numbers. So we're just going to grab the 3. The 14 we're going to say is the length. The 5 we're going to say is the width. And then the 2 is going to be the height. Now that could vary depending on how you end up folding the box. So depending on which base you use as a base. But we just need the 3 numbers. So we're going to go ahead and plug them into our formula. So volume equals length times width times height. We can use our Desmos here, so you can do that if you like. And using our Desmos, we can just write out our formula if we wanted. Oh no. And we could say LWH, and then I'm going to tell it what LW and H are. So I know that L, I'm going to say, is equal to 14. W is equal to 5. And finally, H is equal to 2. And then you notice it gives us the answer of 140. So you can do it that way, or you may just want to put the numbers into your calculator, 14 times 5 times 2. This is not a very difficult problem to do. But we're going to record that answer here. So our answer, if we put in 14 times 5 times 2, let me look at that again, is going to be 140. And then our units, because it's volume, they're going to be cubic units, because this is a volume problem. I wonder if that tricked some of you because you saw the net and you assumed it was surface area. So be really careful with that. Look at the problem, and from here we had volume, not surface area. All right, I'm going to go ahead and pull my formula over here, my formulas, and I'm going to try to determine this problem. It says a gift box and its dimensions are shown below. What is the least amount of wrapper paper that you could use to wrap this box? Think, where do you put the wrapping paper? It's a good question. So we're looking at the wrapping paper that we're going to use to wrap the box. So our keywords to help us determine what we're going to use is we're wrapping something. And we put wrapping paper around the box. So for this one, we're going to use surface area. Do something real here. Okay, so I'm going to pull this over here. So we're going to use the surface area formula. It's a rectangular prism again, and we're going to use the surface area formula. So for surface area, it's going to be 2 length LW, length times width, plus 2 length times height, plus 2 width times height. And then we're going to tell Desmos that L is equal to 8, W is equal to 4, and H, the height, is equal to 2. So now we've set ourselves up, and now we can just put that into our calculator. Pull that over here. And I'm just going to put that in. Clear this out. So it's going to be 2 LW plus 2 LH plus 2 WH. Okay. And again, we want to double check that we typed our formula. Be careful that you're not using ones for L's. I know some of you were making that mistake earlier in the week. So now we're going to go to the next line and we're going to tell it L is equal to 8. And still it hasn't solved it because we don't know what W or H are yet, or Desmos doesn't. W is equal to 4. And then our last line, H is equal to 2. All right, and you can see our answer there. We got 112 simply by typing in the formula and then telling Desmos the values of length, width, and height. So I'm going to go back over here, put in my answer. So it's 112, and our units are inches. And since this is a 2-dimensional, the paper is flat. It's not 3-dimensional itself. This is going to be square units for surface area. Okay. Moving on. Okay, now we have some cylinders. So the first one, we're going to find the volume of that cylinder. So I'm going to bring my formulas down. You guys should have these formulas. So we're going to look at this problem here, and we're going to find the volume of a cylinder. So cylinders, this shape here is our cylinder, and we're finding the volume, so we're going to use this formula. So we're going to write down our formula. Volume equals pi r squared, which is radius, times h, which is height. And now we're going to identify what we need in the problem. So I know this is laying on its side, but you can see where the circle is. So where the circle is here, you can see that this line goes all the way across. So that means that the diameter is equal to 8. The problem is asking us for the radius. So if the diameter is 8, we need to take 8 and divide it by 2 to get our radius. So 4 equals our radius. So we need to be careful with that. If they give you the diameter, you need to divide it by 2 to make it the radius. And then over here, even though it's on its side, the height is going to connect the two bases. So you can just imagine if this was positioned with the circular base on the ground, but it's just turned to the side. So now I'm just going to plug in my numbers. Volume equals pi times 4 squared times 12.2. And this is an example of me plugging it in, but you can also just put the formula into your Desmos, and then you can tell it what R and H are, but we're going to try this one a little differently. So you can see that there are different ways. So I'm going to clear this, and I'm actually going to put in the formula with the numbers this time. So pi times 4 squared times 12.2. All right, let's double check. I have my pi, I have my radius, which is half the diameter, and then I have my height. I multiply them together, and I get 613.238886. So I'm going to round this to the nearest tenth. So my answer is going to be 613 and 2/10. 613 and 2/10 of a millimeter, and this is volume, so it's going to be three-dimensional. We're filling it. All right. Now I'm going to move my formula sheet so we can look at the next problem. All right. So this says the truck's tank is a stainless steel cylinder. So again, we're going to be looking at that shape again of a cylinder, and we're going to find this time the surface area of the tank. So maybe we're painting it or something like that. So we're trying to figure out just the surface of the tank of the truck. So for this one, again, we have our cylinder formula, and we're going to use the SA, which stands for surface area. So surface area, surface area is equal to 2 pi RH plus 2 pi r squared. And what we need to solve this is we need our R value and our H value. So we're going to look at our picture, and it gives us the value for R. It tells us that the radius is 4 feet. And then the 50 is going to be our height. It's the distance between the two circular bases. So this time, I know that R is equal to 4, and I know that H is equal to 50. This time I'm going to use Desmos by plugging in our formula. So if I grab my Desmos calculator, move it over here, and clear it out, I'm just going to type in the formula for surface area, 2 pi r squared. Oh, excuse me. Oops. 2 pi r H plus 2 pi r squared. Actually, that's reversed of how we've been writing it in class. That's okay. So this is giving us our formula a little different, just backwards, but that's okay. 2 pi RH, that's going to be the lateral area, plus 2 pi r squared. So again, in class, the formula sheet that I gave you was 2 pi r squared plus 2 pi RH. So this one's a little different. It's an older formula sheet, but it's still the same thing, just reversed. You'll get the same answer. So we're going to go to the next line, and we're going to tell it that r is equal to 4. And then the last line, we're going to tell it that h is equal to 50. And it gives us that really big number, 1,357, and we're going to round it to 2/10. So that's your answer, 1,357 and 2/10. And then this is surface area, so it's going to be square feet. Okay, and these are some basic surface area and volume problems. Oh, the formulas are right here on the bottom. So you can see the one that we just looked at with the formulas I was using, so just so I could have it up there, it reversed these two. But again, we know the commutative property says it doesn't matter the order when you're adding two things. So either way, we'd get the correct answer. All right, last page. Now we're going to look at some multi-step problems, 4 multi-step problems with volume and surface area. So the first one, Jenny's going to paint a wooden box that's 12 inches wide, 8 inches tall, and 9 inches long. If one bottle of paint covers 100 square inches, how many bottles will she need to buy the entire outside of the box? This is just like our problem of the day. So let's think about it. Let's look first at the dimensions. We know that it's a box, so it's a rectangular prism. It's 12 inches wide, 8 inches tall, 9 inches long. We are using paint, and the paint is covering. So because it's covering, we know this is going to be a surface area problem. And because it's a wooden box, we know that it's going to be a rectangular prism. So the first step, there's some more stuff that we're going to have to do because it is multi-step. We're going to have to figure out how many bottles she needs to buy to paint the entire outside of the box. And one bottle covers 100 square inches. So the first thing we're going to do is calculate the surface area, which is 2 length times width plus 2 length times height plus 2 width times height. And then I'm going to tell Desmos that the width, W, is equal to 12. Our length is equal to 9. And it says tall, so our height is equal to 8. I'm going to put all of that into my calculator. Put my formula. 2 length times width plus 2 length times height plus 2 width times height. And now I'm going to tell Desmos that L is equal to 9 and W is equal to 12. And then finally H is equal to 8. And that gives us the answer of 552. So that means that it's going to take 552 square inches to paint this box. But the question isn't how many square inches are there to paint the box, it's how many bottles. And I know that each bottle covers 100 square inches. So for this one, we're going to figure out how many times 100 goes into 552. And if we do the math here, 552 divided by 100 is going to be 5.52. Now this answer is bottles. So let's think about it. If I need 5.52 bottles, I'm not going to buy 0.52 of a bottle. I'm either going to buy 5 bottles or 6 bottles. And in this case, we're going to need 6 so that we'll have enough. We'll just have a little left over. Maybe if we spill a little bit. And that was 2 different steps. You found the surface area, and then you had to figure out how many bottles it would take to cover the box. All right, the next one, we're looking at a can of Coke. So we're looking at, think about that, a can of Coke. That's a cylinder. And we know that the height is 4 inches and the radius is 1 inch. And the question is, how many cubic inches of Coke would be needed to fill 8 cans? So let's think about this one. We know it's a cylinder, okay, because it's a can of Coke, and we know that we're filling it. So this is going to be volume of a cylinder. Volume of a cylinder is pi r squared times height. We know in the problem, it tells us the height is 4 and the radius is 1. So we're just going to use our Desmos calculator again, using this formula. I'll pull it over here, clear this out, and we're going to put in pi r squared height. Go to our next line. R is equal to 1 and H is equal to 4. All right. So that tells us that we're going to go ahead and round this to 12.6. So using our formula, plugging in our numbers, it's going to take about 12.6 cubic inches of Coke to fill 1 can. So it's going to be 12.6 cubic inches per can. But notice the question here is not asking how much in 1 can, it's asking how much to fill 8 cans. So now we're going to take this number and we're going to multiply it by 8. And if I multiply by the 8 cans that I'm going to need, I go back to my Desmos. In fact, I'm going to go just clear this and use 12.6. It's approximation times 8. And I get 100.8 cubic inches. So 100.8 inches cubed. And again, that's because this is 2 steps. We had to figure out the volume, and we also had to figure out how much it was to fill 8 cans. Last 2 problems. Davis has a moving box that is, the dimensions are given, 6 feet wide, 7 feet long, 8 feet tall. And we want to know how many smaller boxes that are 24 square feet can fit inside the larger box. Okay, so the larger box, and we know this is a box, so it's a rectangular prism. And since we're fitting something inside, it's going to be volume. So this is a volume problem. First, we're going to figure out the volume of the moving box. So I'm going to multiply the length times width times height. So that's going to be 7 times 6 times 8. So I can get out my calculator, I can put in the formula, or I can just multiply those 3 numbers, 7 times 6 times 8, and I get 336. So it's 336 square feet of room. That's how much room I have in the boxes. But now I'm trying to figure out how many of these smaller boxes can fit inside of this large box. So what I'm going to do is I'm going to divide this number by the 24 square feet to see how many of those would fit inside. So I'm going to go back to my calculator and I'm going to type in my answer that I already have. I can take it to the next line, bring down my answer, and then I'm going to divide that by 24. And if I do that, I get 14 boxes. And that is one of my choices. So the answer is A. Okay, last problem. We're looking at what shows the correct substitution for finding how much aluminum is needed to make the can of oranges below. So when we're thinking about the aluminum that it would take, the aluminum is not inside the can. The aluminum was on the outside of the can, actually needed to create the can. So this is a cylinder, and for this one we're going to calculate surface area. And our surface area formula for a cylinder is 2 pi r squared plus 2 pi r h. So now let's think about, so we're going to go ahead and substitute the numbers in and then compare it with the numbers below. So I can see down here that the choices, they're using 3.14 for pi, so I'm going to use that for pi as well. So I'm going to say surface area is equal to 2 times 3.14. It gives us the radius, right? That's our radius. The 11 is going to be our height. So 3.14 times 4 squared plus 2 times 3.14 times radius, which is 4, times height, which is 11. And we're going to look down and see which of our choices matches this. All right. And it looks like it's this one here. B is the correct answer. We have the 2 times 3.14 times 4 squared plus 2 times 3.14 times 4 times 11. So this would be our choice. All right, that wraps up our study guide review. Good luck on your test.